Hello, my name is Alan, and I have the pleasure of introducing the work that I, along with my colleagues Adol, Naina, and Nico, worked on this past quarter. First and foremost, we would like to extend our gratitude to our TA and mentors, Avery, Trevor, and Caleb, for supporting us in this project to Carbon Cabinet. Our client is Carbon Cabinet, as mentioned, a grantee of the 11th Hour Project, which is an organization that supports qualified organizations and social enterprises through grant making and impact investing. Climate Cabinet functions much like a climate staffer at scale, analyzing local climate and governance data and focusing on climate solutions as they interact with other critical issues such as the economy, public health, and racial justice. They deliver local climate talking points, messaging, policy solutions, and incumbent voting records to their clients across all levels of the U.S. government. Part of Climate Cabinet's role is to provide background and analysis on the cash flow of state and local campaign finances across the country to better inform candidates on their the pain points, direction, constituency, etc. This information can then help their clients better coordinate their campaign resources and direct their attention to the most relevant aspects of their race. This is the issue that we will be most relevantly tasked with in this project. To be more specific, the problem that we are solving for Climate Cabinet is in state and local climate races, in state and local climate races, what is the disparity between campaign contributions from fossil fuel political action committees and clean energy political action committees, which is what the abbreviations PACS here stands for. Our deliverable will help Climate Cabinet track how and where various entities, such as corporations, PACs, or individuals direct their donations, allowing their clients to better allocate their campaign resources. Ultimately, our project sets out to test Climate Cabinet's hypothesis, namely that fossil fuel interests will influence electoral spending, which halts progress in climate policy. Our goal for this project is to deliver a pipeline to analyze the complexities of campaign finance data and build a network graph to visualize and understand the nature of donations to local candidates. Climate Cabinet envisions the network to look much like the one to the right here, where each node represents an entity, such as a lobbyist, private citizen, corporation, and each edge represents the transactions information between each node. The colors would differentiate the entities classifying them as connected to the fossil fuel industry, clean energy industry, or neutral. I will go further into these details later in the presentation. Using our visual and several key metrics, we can begin to understand where the key players are and where their influence is established. Now, we'll be discussing the process that we use to accomplish our task, which includes cleaning data, building a pipeline for record linkage and classification, and building the network visualization and metrics. Step one of our project was to ensure that our data was usable. Last quarter, the climate group worked and built a pipeline for approximately 380 gigabytes of campaign finance data from Arizona, Michigan, Minnesota, and Pennsylvania. The data totaled over 700,000 individuals, 100,000 organizations, and over 5 million transactions, principally between the years 2018 and 2023. In the best cases, we had access to the full names, addresses, occupations, employers, by the states of the individual subjects, and the names, states, and types of organizations in the organization base. But in many cases, some combination of these features were missing, which made linking the different entities problematic. Thus, cleaning this data involves standardization steps like building columns such as street address, political affiliation, transaction amounts, etc. The result, 3 data tables as shown here. We have an organizations table, which includes PACs and corporations, an individuals tables, which includes regular individuals, candidates, lobbyists, and a transactions table, which shows transaction amounts between recipients and donors. We can connect these tables together to the unique organization and individual IDs, which match to the donor and recipient IDs here. To make the data easier to work with, it is important to remove duplicate information. We employed both deterministic and probabilistic methods to link various entities together in a process called record linkage. Record linkage refers to the task of finding records in a dataset that refer to the same entity in the same dataset or across different datasets. We first dropped identical rows, then we dropped entities who had identical attributes except the assigned IDs. Finally, we used Splink, a probabilistic record linkage library that employs a blocking system to separate our dataset into chunks of likely matches. which you can then analyze and match up using similarity functions, which makes pairwise comparisons and accepts matches beyond a certain threshold. It was important for us to retain all the UIDs of the duplicate entries so that we could work backwards if need be. Step 3 in our process was classification. In an effort to better understand the influence of the fossil fuel and clean energy industries, it was important to classify each entity under these terms. Ultimately, we chose fossil fuel, clean energy, and neutral. Classification was mainly a manual process, combining lists of the largest fossil fuel and clean energy companies and PACs with a search of the top donors in each dataset. We then used this information, these manual classifications, to categorize individuals and organizations based on their employers and names respectively. In the course of classifying our data, we found that there was much more sparse than expected. Though we had gathered the names of many fossil fuel corporations, executives, and associated political groups, only a small fraction of this data appeared. A fraction of these actually appeared within our data. This is important because it highlights the challenge of directly affiliating organizations and corporations to the fossil fuel industry. We also found that there are very few organizations in our dataset dedicated specifically to clean energy advocacy. We postulate that since such spending tends to be wrapped up along with environmental issues and conservation efforts, tracking the influence of that industry is a bit more difficult in comparison. With the details of our pipeline fleshed, I will now discuss the final piece of our project, the construction of our graph and the visualization. Before we begin to construct the visualization, we merge the XT tables produced by the pipeline before, remember using the donor IDs and the recipient IDs to link the transactions table and the organization's individual state. We then used the Network X library, which allowed us to build a mutable network graph object from the data, where each node once again represented the entity and each directed edge represented transactions between different entities. We split the data into node-specific attributes such as name, address, and edge-specific attributes such as the donation amounts, the year, and the intended office. We will see this in action in the next few slides. At last, the visualization results. Once more, here's the reference graph that Comic Cabinet shared with us. For the purposes of visualization, we limited our sample to 75 entities so that discussion metrics could be done in a simpler manner. Without further ado, here's our network graph. As you can see, our nodes, which are entities, are connected via directed edges, which means that they show the direction of a transaction as demonstrated by the arrows such as here, for instance. We clearly see the development of some clusters within the network. And so for instance, let's zoom in into this particular cluster. Once we zoom in, we can see that each node has its relevant attributes attached to it. For instance, here we have a Lester owl. We also have information about Lester that is particular to Lester, such as their address, their city, the employment information, and all that factors. We can also see that all these entities are directing their nodes to this particular entity here, which happens to be called the Democratic Legislative Campaign Committee. And this entity is also classified as neutral. Following some visual and exploratory analysis, we can use various network metrics to contextualize our network. One of the important metrics to consider when thinking about influences in our network is who are the key players. Using the measures of centrality outlined here, we can determine some of those key players. In degree centrality is a measure of degrees going into a node, so it can tell us who is receiving the most contribution, while out degree tells us the opposite in terms of who is giving the most contributions to other entity campaigns. Eigenvector centrality is a measure of how connected a node is directly and indirectly, so it may tell us which nodes hold the most influence. And finally, betweenness centrality is a measure of how often a node bridges an interaction, so it can tell us about entities that facilitate a lot of transactions between other nodes. We can also consider some overall network metrics. Density, for instance, is the number of edges divided by the number of potential edges, so it can tell the extent to which entities are connected and engaged in financial transactions. Partial activity tells us how often similarly classified nodes are interacting with similarly classified entities. Basically, this will tell us how often entities are reaching across the aisle in terms of financial contributions. We can also start to build communities where each cluster is entities, communities of clusters to indicate the breadth of the entities and how they work together. A small sample of our metrics, we can see here, for instance, that in degree, there was a particular pack that was able to donate generously to a lot of other nodes. Here with the eigenvector, we actually had a really high number for a particular pack called Invest in Education Community, which means that this node was at the center of a lot of other transactions. It could be more like a bridge between multiple clusters. Lastly, here at the bottom, we can see that we have a small sample of clusters. So we can start to group communities of clusters together and see an itemized list of all the nodes that are involved within a particular cluster. With all that being said, we will share the two most salient takeaways from the project. First, from classification, it is cumbersome to classify an HT as fossil fuel or clean energy because most HTs don't exist in such a binary way. There are usually a host of political motivations at play. To further complicate the matter, if individuals might donate to PACs, which can then influence a candidate's political stance on energy production, among other issues, would it then be accurate and sufficient to categorize the individuals who donated to the PAC as being inclined towards the fossil fuel industries? Potentially, but it is evident that there is a lot of gray area. Second, the scale and diversity of clusters that we extrapolated from our centrality measures indicates just how complex the task of tracing campaign contributions are. For instance, as we saw with our eigenvector measures, there are entities that connect to multiple clusters, meaning that money is circulated at various amounts in different clusters. This is an important factor with regards to the world of climate cabinet, because candidates can have a plausible deniability when involved with involvement on either industry by simply citing how convoluted the chain of relation flow truly is. Thank you so much for your time.